See Lindelof videos, AP Calculus, second fundamental theorem of calculus. I want to talk about a couple examples where the upper limit is f of x instead of x because it gives us something a little bit different. So starting with the idea that I'm assuming that you're cool with this, that the derivative ddx of a definite integral a to x of f of t dt is just f of x. I proved that in the last two videos, but this one I just wanted to show you a couple of problems that you might see. So let's look at this. Start out, we say our function is strange because our function is actually a definite integral from 2 to x squared. And this is what makes it a little bit more tricky. If it was just to x, we could just put in f of x. But here we have to do something a little bit different of t to the negative 3 dt. So the two things that we're going to have to remember to do here are these. First thing I'm going to do is where I had t, so I have t to the negative third. So there's my t to the negative third. I'm going to plug in this entire value, not just x. When it was just x, it worked really cleanly, but we have x squared here, so we have to put the x squared here. So this x squared is this one. This negative 3 is this one. All right, so far so good. Times the derivative of this. So what's the derivative of x squared but 2x? And this is us finding f prime at x, right? Because remember, it says here we're going to find this derivative. So here, I'm going to do this. I'm going to clean this up. We get x to the negative 6th power times 2x. So we can say with great certainty that f prime at x is equal to 2x to the negative 5th power. So let's try another one. I'm just going to do 2 or 3 and see if we have this thing straight. So here's a new function. Same thing we did before. I'm going to say that our function f of x is equal to the definite integral 0 to x cubed of sine of t squared dt. Something to really think about here is this. Sine squared t and sine of t squared are two different things, fundamentally different, and we can talk about that at another time. But this does not say sine squared t. This does not mean sine t times sine t. Here we have the argument is squared. So we're going to do the same thing that we did in the last problem. We're going to start out, we're going to say that our f prime at x, is equal to, we have sine, don't we, of t squared. We're going to insert our upper limit, which is x cubed. So my x cubed goes here, right? Times the derivative of this. And the derivative of x cubed is 3x squared. Now, here we have to be especially careful. I see these x's together. This is not true. As I say, we can't multiply these x values together. This is sine of this thing. So this x, it's going to be to the 6th power, is connected to sine. So we have sine x to the 6th power times 3x squared is our f prime at x. All right? Hopefully we're getting somewhere. I'm going to do one last example, and I'm hoping you're going to get this. This is not a big part of the AP exam, but hell, you might as well get the free points, and it's not especially difficult. So let's go ahead and do this problem. This problem, we're going to say that our f of x is equal to the definite integral 0 to x squared. So we have something different than x, so we know we have to do something a little bit different. Sine theta squared d theta. All we're saying here is that our replacement, our temporary variable, is theta. And we're going to go ahead and follow through on this just the same way we did before. We're going to set up this little shell and say that we had sine theta squared. Our replacement value, right, this is just a temporary variable, and this is what's going to go in there. So we're going to put in the x squared. This x squared obviously is this upper limit here, times the derivative of x squared, which happens to be 2x. So we should get 2x sine x to the 4th power. All right? So I hope this is really helpful. This is not especially difficult because you're not going to be asked to explain this on the AP exam, but you are going to have to do it. So hopefully this is helpful. If you have any questions or comments, let me know. And if you haven't already subscribed, please do. Thanks.